All right, let's go ahead and get started. DZone is proud to present Increase App Confidence using CICD and Infrastructure as Code, brought to you by CircleCI. I would like to introduce you to our presenter, Angel Rivera. Angel started his career as a U.S. Air Force Space Systems Operations Specialist in Cape Canaveral AF Station, where he realized his passion for technology and software development. His technical experience includes military and space lift operations, technical writing, software development, and SRE or DevOps engineering. I'd now like to do a quick sound check for Angel. So Angel, please say hello to our audience, and audience, let me know if you can hear him by posting a message into the chat panel.
Test. Hello, everyone. I'm excited to be here and giving this presentation today. Can you hear that?
Awesome. It looks like we are able to hear that. And now I'd like to pass it off to you for the presentation.
All right. Thank you so much. Really excited to be here. I wanted to give a fresh new talk, or actually I've given this talk in a different format, different way previously. So today you're getting a little bit of a fresh new look, fresh new format, fresh new content regarding this talk. So yeah, let's get into the agenda, which is basically a quick introduction to myself, and I will go really quickly with that since I got an awesome intro from the organizers. Then I'm going to talk about testing, specifically smoke testing. Then we're going to go into why deployments break, right? Like, why do we have this, situation where we deploy code and it worked in a development environment or on your laptop, but it doesn't work in production. Then we're going to talk about increasing the app confidence or release confidence, right? Which requires you to kind of, or at least not requires, but encourages you to test releases for the target environments that you're going to deploy to. And then I'm going to show you a demo, which is really what I'm excited about. So go into kind of showing you pipelines, infrastructure as code, and running smoke tests within all of those things, right? So that you can get the highest confidence with your releases as possible. So before we get into all of that, again, my name is Angel Rivera. I'm a developer advocate at CircleCI, and in my role as a developer advocate, I get to engage with the developer community about all things technology, right? And my main purpose is to learn how people are using technology, how they're developing software, how they're deploying software, how they're testing their software, right? All those little bits that help get developers from idea to actually pushing code into production that their users or communities are using. If anyone wants to reach out to me, I'm really heavy on Twitter these days, so just reach out. My handle is at punkdata. I'm down to talk about anything you want to talk about these days, but yeah, just reach out on Twitter, and we can have some conversations. So let's start off by talking about testing, right? Which is essentially a lot of folks that get this, not that they understand what testing is, but I think it's testing in the context of software development, right? Just kind of cover some of the basics. I like to do that in my presentations to kind of level set folks who are not as experienced or educated or knowledgeable. So obviously, right, testing just validates test cases, and test cases are things that we are comparing. So, we're looking for a specific result, and then, or at least we're expecting a certain result, and then we verify that the execution of our code is producing those expected results. So we're just doing comparisons, right? So that's all testing is comparing things with the expected results, right? And there are multiple types of testing. And here's a list of multiple types of testing. We have unit tests, right? That's centrally, like generally when the developer's building things locally, maybe it's some new functionality, they're building these small tests to kind of test that specific functionality. It's a very limited in scope. Smoke test, again, very limited in scope, but these are a little bit more, I would say, comprehensive than unit tests, but not by much. The top two, unit tests and smoke tests, are designed to be really, really quick tests that you can do or that you can perform against code, right? And I would say situations as well, where smoke tests kind of encompasses situational type testing, but it's supposed to be really, really fast. And I'll get into a little bit more about smoke testing in a moment. And then the other three, functional tests, integration tests, and regression tests, those are generally more comprehensive, more expensive. Those tests are essentially larger in scope, generally slower because they are larger in scope, right? They're performing many comparisons, many tests on a specific set of code, or maybe even the whole application. But just keep in mind that unit tests and smoke tests are designed to be super quick, right, and give you kind of a really quick verification of your application, and it's testing the core concepts or essential concepts and functionality of the application. Now, if we're talking about smoke tests, they're basically a simple preliminary testing that reveals failures, right? Just like any other test. But again, keep in mind that these are super fast, super simple tests that kind of suss out any easy to find bugs, right? Or maybe there's situations where your application will fail because of some silly, misconfiguration or something like that. These are just really quick tests to suss out that you have at least a valid working release. Again, it'll quickly verify essential functionality before executing more comprehensive testing. I have a story about smoke testing. So back in the day when I was in high school, I used to work in construction jobs, right, in the summers. And I was working with a set of plumbers one summer. And the plumbers basically, we were in a facility and they were building out a new copper kind of plumbing system. And I noticed that they built all this, plumbing out. They were soldering the joints together and making sure that, everything was connected. And when they were done, I was expecting them to go ahead and maybe, connect the hose to it or some sort of water supply. And that didn't happen. What they did was they connected a smoke canister. It's a canister that can produce smoke, or a device that produces smoke. And they fed it into those pipes. And I was wondering, why would you do that? And so in speaking with the plumber, they basically said, well, the reason why we're pumping smoke through all of these pipes is to see if we have any leaks, or if any fittings were not properly soldered or connected. And it still didn't make sense to me. But then, after just watching them do it, they tested the plumbing, and there were no leaks, or no smoke was escaping. So the next test they were going to do was basically a pressure test, which is they just connected this air compressor to one end with the gauge, they soldered it on, and then they just filled those pipes with air. And they let the gauge sit there overnight. And obviously, right, they had a certain amount of pressure that they had put into the pipes, air pressure. And then the next day they came back, the pressure was still the same. So that was, kind of another test that they did to make sure that, there was no leaks in any of their connections. And then finally, they connected the water supply and then just ran water through it. So the point of that story is, they did the smoke test. So when I started developing software, it kind of clicked right away when I heard the phrase smoke test. And again, right, it was a quick and easy, very unintrusive test that they can perform to ensure that that their fittings were all sealed properly. And that helped them with kind of speeding up the process as well. So if there was any smoke escaping, you could quickly verify where those leaks were, mark them, and then resolder all that stuff. So if you think of smoke testing and software development, same kind of concept, right? You just want to do things, test things really, really quickly without a lot of expensive effort. So now that we covered testing, let's talk about broken deployments, right? So when we're deploying software, as a developer, we're always, sending off our releases, and sometimes the problems that we're having are generally because we haven't, tested it in the target environment. Now, in modern day software development, we're all probably, as developers, we're all probably leveraging continuous delivery. And if you don't know what continuous delivery is, it's basically the way that a company or teams actually build their software. And the concept there is you're building software at a really fast pace, right? But you're also not only writing code, you're testing the code, and then you're also doing the other things and processes, that are required for that specific software, and then you're delivering those changes, right? So the concept of continuous delivery is kind of like the parent to CICD. But again, right, the continuous delivery, it is what it sounds like, right? You're continuously delivering releases of your software. And that's done obviously using automated tools like CircleCI. So within continuous delivery, we have this concept of CICD. I'm sure you've heard of this quite a bit. I'm sure some of you are familiar with it. But for those that are not familiar with it, CICD basically stands for continuous integration and continuous deployment. And in continuous integration, all that really means is software developers, right? We're developing software in kind of an isolated way, but we're basically we're all working off of a shared code repository. So what we're doing is taking snapshots of this master kind of repository or branch, and then we're working individually on our own development environments, right? So I may be building some functionality to add users to a database. Someone else may be working on displaying the list of users in a database, right? But we're all working in separate instances of that code repository. And then when we're done, when we think we're done, we push our changes up to that shared code repository so that, right, everybody can kind of collaborate around that code. And if you look at that diagram I have there, all the way to the left, we start with the code, right? And in the GitHub icon there, you have what I represent as the shared code repo. And then you have the CI/CD runtime that kicks in. And that only kicks in when code is changed in that repository. And then, right, you're doing some testing, you're scanning your applications for any vulnerabilities, and then ultimately you're going to build an artifact, which is kind of the binary or some sort of packaged up representation of your application. In this case, we're going to build a Docker image to deploy to some container runtime. With continuous deployment, CI or continuous integration deals with actually developing software. Continuous deployment is the practice of just deploying that software, right, using automation. And when you're using a continuous deployment, it can get really tricky, right? So there's some companies and organizations and teams that do it a little bit differently, and that's okay. But the one thing that I will say is when you're, implementing some sort of continuous deployment, make sure that you're implementing something that works for your team and your specific situation, because not all deployments are the same. So this is what I call a happy path deployment, right? Some people or some folks that I know, they kind of get into this groove where, they're building software, they're using their CI/CD tools, and everything's always green. And that's okay. I wish all of you the best, and I hope that that's your situation and it stays that way. But the reality is these pre-deployment results can be very deceptive. And what I mean by that is ultimately, like, deployments fail, right? And they fail unexpectedly. There's many reasons for it. And if they do fail, don't feel bad, right? That's actually a good thing, because you know that you have a problem and you can fix it before any of your code hits, right, production, or it should be that way. But sometimes people have these continuous deployment pipelines or CI/CD pipelines that just automatically deploy code, and they do all the CI work, test everything. When it gets to the point for deployment, the application actually deploys okay, and that's expected. But the issue is post deployment, the application starts behaving a little funky, right? So did the application actually deploy okay just because it's running on a server, right? Maybe there's some changes that happened in some configurations or something that cause problems. And this actually is very common, right? So even in your CI/CD pipelines, when everything is kind of clean and green and deployed successfully, you still have an issue with the production or the application. You can still have an issue with the application not running properly or as intended. And that, again, can affect your users, right, downrange. So here's some of the common post-deployment failure reasons that I've encountered. The number one is defective configurations, right? So this is where in the CI/CD pipeline, everything's kind of great, configured properly, it runs perfectly. Then you deploy it to the production environment, and then you're deploying a whole set of different configurations. And for whatever reason, right, there could be problems like maybe the syntax is not properly formatted, or whatever the reason is for these defective configurations. It does happen, right? There's always, when you're moving between target environments, there's always going to be a configuration change, and those are that's the top number one reason for a deployment failure. Integration faults. This is where you deploy the application and you have maybe multiple services that application or that release depends on, right? It's external to the actual release. There's issues maybe with networking, routing traffic to these other services. So that's where integration faults come in, which is very common as well. And then obviously, right, you have the case where you just don't have the right passwords, credentials, or your service is not authenticating to another service that it integrates with and it's dependent on. These are all common like post-deployment failure reasons. So we've kind of identified testing. We identified deployment failures, right? Some of the things that cause it. And what I want to talk about now is how you can help increase the confidence in your releases and your builds. And doing that using the tools that you probably already have at hand. So again, we're developers, right? With continuous delivery being our kind of gold standard of software development, we're encouraged and we're expected to go fast, right? But I always like to say, yeah, we can go fast, but we should go fast confidently and reliably, right? Because if we're going fast and we're just, building software quickly and not really doing a lot of quality kind of control on that, it's going to be a huge problem, right, for your team, your company, and ultimately your users. So with with that concept of going fast, confidently and reliably, you definitely want to verify these deployments, right? And one of the ways, again, that I like to use, even before it hits like a production type deployment, is to verify these deployments using smoke tests in the actual target environments where they're going to be deployed to. Just because of the nature of smoke tests, right? It's super simple to implement, and then also gives you kind of a couple insights into what's going on. Now, this is from the same kind of visual from the previous example I showed you of failed production deployments. Again, I just want you to notice, right, that with the environment that we're looking at here is a pipeline that actually just, right, goes from code, change all the way through to pushing the image or the application to a production level Kubernetes cluster. And right, let's say we have some problems with maybe a configuration. The application therefore is erroring out, and then our users are not able to access it. So that's a do. So this right here is an example of testing the release prior to a final deployment. Now, in this slide here, it's a little different, right, than the stuff that I've shown you earlier. And it's primarily different in this zone right here, where we're actually, building the image. And then the next step is to create the target environment. And in this case, we're using a Kubernetes environment. And with that, we're going to go ahead and also deploy the application, which is the new release. And then we added a couple extra steps here, right? So in this pipeline, we're going to go ahead and run a smoke test against the application running in that target environment. So not only are we like, building the image, we're scanning for security, we're testing like at unit test level, whatever. We're also testing the environment that we deployed to, which is actually something that's very, I would say, very newish, right? Like this is not something that has been done. Normally they set up monitoring tools and stuff like that, but that's always at like the production level or staging level type environments. What I'm proposing here is doing this every time in your CI/CD pipelines, which with the modern day tooling isn't really expensive at all, and will give you that right application kind of confidence. But the cool thing here is once everything's kind of set up, you can then destroy all of that infrastructure that you created. And now you know that this application has run in the environment that you're targeting, and it performed well. It passed all your tests. And again, right, smoke tests, they're not very deep or comprehensive, but they kind of suss out any of the easy kind of bugs that you need to detect and figure out. So here's a visual representation of the demo I'm going to give you today. This is actually cribbed right out of the CircleCI dashboard for the project that I'm going to show you. As you can see here, right, there's a lot of things going on and there's a lot of jobs. So this is how it would look like visually in CircleCI, but I'm going to get deep into like the code visuals of this as well. So again, right, so when you're deploying these new releases, you can definitely leverage smoke testing, right, to test those target environments or test the application within those target environments and how it's functioning. You can develop fast pipelines, right, using smoke tests, and that actually serve a purpose, which is to test those releases in the target environments. And they help because, again, right, smoke tests are supposed to be super fast and very limited in scope, right? And you may be asking like, okay, so how do I create all this infrastructure, right? Isn't that more code? And the answer is yes. You're gonna have to employ infrastructure as code, right? You're gonna have to, if you're not familiar with that, I would definitely recommend if you're a developer and you plan on being a developer in the next 10 to 15 years, I'll definitely tell you to invest or encourage you to invest in learning infrastructure as code because it helps with creating and destroying these target environments very easily, right? And it's in a codified manner. So, you don't have to go into a GUI and start pointing and clicking and creating all these awesome environments, right? Which is actually time consuming and a very manual labor intensive process. Infrastructure as code also eases the management and changes to any target environment. So if you are using infrastructure as code to actually create and manage your production level environments or your staging environments, even your development environments, any little change that you make is so easy to kind of make and then track because it's all in code. And then you can also version those changes as well, right? So there's always that kind of audit log and history of what had occurred in those environments. Again, infrastructure as code is really helpful in helping you gain velocity in your builds and also managing all of those infrastructures, right? We work with a ton of customers and some of them have like hundreds of infrastructure, right? Like clusters of servers. If you had to go into a dashboard and manage them by pointing and clicking, it would be almost impossible, right? Or you would have to hire a huge army of operators or developers to manage all that infrastructure. So highly encourage you and advise you to definitely look at infrastructure as code. So let's see. I'm going to wind down now, and we're going to talk about the benefits of smoke testing in target environments, right? So you're going to gain some valuable insights. You're going to expose these easy to miss bugs. So, I can tell you how many times I've spent hours and hours looking over, the same lines of code, hunting for these simple bugs. And then like 2 hours later, you go, oh, wow, it was that little thing, right? That I missed. And then when you do find that, you can write that into your smoke test so that in the future, it's testing for that as well, right? And then you're verifying the application behavior, which is really important within the target environments, right? This is what I've been kind of harping on this whole presentation is, deploy your application while you're doing your testing into the target environment so that you know that that application is behaving as intended in that environment that you're going to deploy to. And obviously, right, if any of those things fail in your deployment testing, go ahead and fail those rejected software builds, right? Like, just don't even try to deploy them into production because it's just going to, add more problems. It's just not necessary, right? So, covered all of the things I wanted to cover in this slide deck. So I think let's jump into a demonstration real quick. So let me jump over to my screen here. Okay, great. So what I want to show you is basically the code base that I'm going to use today. This right here is a simple Node.js application. And what we're doing here is we're going to go ahead and change the number. Now, the application isn't a big deal, right? Like, this is not the focus of this talk. But what I want to show you is kind of how a pipeline can be built to test all this stuff. And what I'm going to do is change this version number here so that, right, the application has changed. And as you can see here, we got to change. I'm going to stage that change. Normally I do this in a terminal, but I'll just stick to the GUI, maybe show somebody something new. And let's just say, what the change is updated version number. And what I'm going to do in this demo is create a Kubernetes cluster as well as do a lot of pre-processing of my pipeline. So let's go ahead and just push that change up to GitHub. Now, the way CircleCI works is it detects the changes once the upstream repo, right, that shared repository and continuous integration is changed. And shortly here, we should see that, yeah, it detected my changes, right? Detected that push. The code has changed. If I click into this pipeline, which is an instance of one of my builds, I have a bunch of jobs running in parallel here, right? So I'm scanning my application. I ran some unit tests. Remember the unit tests that are quick and easy to run. And as you can see here, you can see my test results. Well, no test results. All right, let's see. Run unit. Here we go. That's a unit test. So what's happening here is it tested my application, excuse me, locally. And then finally, I uploaded those results, right? So with CircleCI, everything's pinned to the actual build so that, if anybody wanted to go back behind you and maybe there's a bug later down the road, you can actually, click through all your tests and see that here's the results here and see that, right? Well, all these tests ran. Now, you could add a couple more things here. Obviously, there's more things you want to test, but the point is, you have these specific jobs that do specific things in your pipeline. It's all segmented out, right? So if I click back in right now, as you can see, and this is going to take a bit of time, so we'll just jump into a little bit of looking at the code. But what I've done here as well is I used security scan, right? So I'm using a platform called Sneak. They are an application security tool that scans for vulnerabilities. It scans Docker images as well. So you can do some static analysis on your applications. And here's kind of like what it looks like. You can see here I have a few bugs, or not bugs, but vulnerabilities, right? They're tied to the dependencies. I have a high severity. Normally I would fix that, but there's sometimes where, right, that doesn't matter depending on the organization and the conditions that you're working in. But it does give you a little bit of also some mitigation, right? So like, it tells you what's going on, and then you can also implement some of their fixes, right? So which is here, right? You're upgrading things. So that was the security scan. If we jump back while this is running, what I'm going to do here is show you real quickly what's happening. We're going to build a cluster for Kubernetes on DigitalOcean. If I jump into my DigitalOcean dashboard, remember I talked about pointing and clicking. You're seeing here, right, that this is all being created in my pipeline fresh. This is a brand new Kubernetes cluster that I'm treating as ephemeral, which means, I don't care about it because it's just going to be used for testing. So Now that that's running, let's go ahead and jump back over to the actual code, right? So that's more important, I think. There's a lot going on here, so I'm not going to cover everything, but what I do want to cover is the big bits, which is how I'm leveraging CircleCI. So this is the CircleCI config.yaml file. So if you look here in my project, I have a .circleci folder, and then within there we have a config.yaml file. This is the directives for the actual CircleCI build, right? This is your pipeline essentially in code. At CircleCI, the only thing that we like show in a, I would say, graphical interface is the status of your builds, not necessarily building your pipeline, right? So there is no way to build a pipeline graphically. And the reason is we believe in code as configuration at CircleCI. We're developers, right? Like if you have to go into that GUI and start, building your pipelines in a GUI, you're very limited. I don't know if you've ever tried to do like very complex things in GUIs, unless the graphical user interface is built or designed to handle like advanced features or advanced things, then you're not going to be able to do it within that graphical interface. Also, I don't know about you, but my experience with like graphical interfaces that try to do everything get so convoluted and so, right, like just confusing and almost unusable. I'm not going to name any names, but there's a lot of like, spreadsheet applications that have a lot of features that you never even touch. So what we do is at CircleCI is we enable the developers to just, handle their business the way they know how, which is, again, configuration as code. So I just want to show you quickly, right? Remember the scan app job that we had? That's basically it. It's a simple a job. So what we have here is a jobs list, and then what you do is you build out, this can be any name, it's just a label, right? And by the way, this is the same kind of structure for almost every job here. So think of a job as like a piece of code that you're going to execute. So a list of commands that you want to execute, but you've kind of grouped them into one thing to serve one purpose. In this case, we're going to scan our application with a static analysis using Sneak. And you always, when you define a job, the first thing you want to do is define where you're going to run that, right? So at CircleCI, we have the ability for you to run your pipelines in what we call executors, which are basically machines or runtime environments where you can, do things in. We've recently added, well, a couple years ago, added Docker runtime. So now you can actually just run your builds inside of Docker containers, which is super easy because now you can just share environments, right, across the board without many changes, or at least they should work as long as you have a Docker runtime environment. And this here is once we have the executor defined, and we're going to use a Docker image, we have to define, right, what image we're going to use. Right now I'm using the CircleCI Node.js image, which basically has Node and all the other Node type related packages installed. And once you have that executor defined, you want to start looking at the steps. And steps is just a list of commands that you want to run within your build. The first thing we want to do is grab our code, right? This is a special command, and it basically kind of boils down to an alias for a git clone, right? So you're just pulling the code into your runtime, and then what we have here is a run command. And this run command basically is just a nice way to kind of, organize your commands. And this command here, I'm just installing, right, the dependencies for my application. Now, the next line here is what we call an orb, and all this is Sneak. The company Sneak we have mutual customers, right? So we have CircleCI customers that use Sneak, and Sneak, we have this concept of orbs where you can actually kind of create, I don't want to say a plugin, but it's more like functionality. They can provide their application into your pipeline really, really easily, and that's what Sneak has done with orbs. And orbs right here, right? So we've defined this at the top. It's just an include statement, like saying, hey, I'm going to use orbs, and then I'm going to use the Sneak orb. And then when you implement it, this is how you would implement it based on how Sneak built their orb. So what we're saying is, yeah, we want to do a Sneak scan, right? So that's the operation that you're going to complete. And these are just some parameters, right? Like, do you want me to fail if there's an issue. I just put false to kind of keep this thing moving because I knew it was going to fail. But you could actually set that to true, and then it would stop at that sneak scan, and your pipeline would just quit right there. And so let's jump into kind of like, we already did the sneak scan. I'm not going to jump into the Docker image because it's similar. All it's doing is just scanning my image and then pushing it to Docker Hub. But what I did want to do is what I wanted to talk about was the creating the DigitalOcean cluster. But before I do that, let's take a look at our pipeline and see where we're at. Great. So it did create our DigitalOcean cluster. And now it's deploying the application. So let's go back and look at the DigitalOcean create DO cluster. And we're going to go through that really, really quickly, right? So again, the same concept, right? You're setting up your runtime. This time I'm using a special image that I built that has a bunch of infrastructure as code tools all integrated into one image just for ease of use. I'm checking out my code again. The next thing I'm doing here, right, is creating, since I'm using Terraform Cloud, and just creating this credential that I need for my code to live it. And as you can see here, right, I just want to show this is pretty cool as well. So as a developer, I'm sure we've all done this, or at least we may even do it in the future. I know I have. We've actually exposed maybe a sensitive data, right, like an API key or something, in our GitHub, maybe in a public repo. CircleCI enables you to kind of keep your secret by establishing environment variables. And then you can actually just basically use an environment variable placeholder in your pipeline, in your syntax, I should say. And then when the pipeline runs, we just inject whatever it is that you defined as the Terraform token into the pipeline so that those secrets are accessible only to that runtime when they need to be, right? Which is a pretty cool thing as far as security is concerned, right? And I just wanted to kind of call that out. And what I'm doing in this command is creating this Terraform file that I need so my Terraform state can be saved to the Terraform cloud. And finally, right, we're going to create the Kubernetes cluster. Now, in this case here, you just got to set up a few names and environment variables. I'm just using the project repo name. These are CircleCI related environment variables that live in the CircleCI runtime. And then I'm going to go ahead and jump into this Terraform DO create, which is DigitalOcean create folder. So if you look here, this is where it's going to jump into. And then it's using all of these Terraform files. So if you look at the main TS, right? Again, it's just more code, right? But it's creating all the things I need. And it's basically super cool because, see, I can tell it, hey, I need like 2 nodes, which means I need 2 servers to host my application. And then, you can look at the variables, which are things that, it needs, could be sensitive data, but you're feeding that into the application so you can make it as generic as possible. And as you can see here, right, with like, I don't know, 42 lines of code, I'm creating a Kubernetes cluster, right? A live Kubernetes cluster on a cloud provider, which is pretty awesome. And if you jump back, what we're doing here is executing, right? So we have to initialize things. But again, right, in like, I don't know, 7 lines of code, I'm creating Kubernetes clusters from my pipeline, which is awesome. So let's go ahead and close this up and then take a look at our deployment. All right, I'm gonna be quick on this one. But basically right now I'm deploying this application to the DigitalOcean, the cluster. So if we look here, we can actually see this happening in real time. I'm gonna jump into the dashboard, and I only use these dashboards to kind of verify things when, just kind of testing things out. But again, this is all part of my test. I'm just doing all of this so that I can make sure my application release is actually functioning within the target environment, which is Kubernetes. So here's the application instances, right? They're running in pods, and they're actually showing up. So this release now is running 3 times, right, within the Kubernetes cluster, which is really cool. So let's jump back here. As you can see, it's still going, right? Like it's still building out. Actually, I think it's done, or at least it finished there. And then the application should have deployed, which is great. Then we're looking at the smoke test. So not only did this application deploy, it also ran a set of smoke tests, right? And as you can see here, the smoke tests are simple, right? I just did a check for an OK 200 response. And then I'm also looking for the static string that lives on the static website, which is welcome to CICD 101 using CircleCI. As you can see here, I automated all of the, like, this is all built from scratch, right? So this Kubernetes server was, or a cluster was stood up using infrastructure as code. Then it also created an ingress load balancer, right? So that the traffic could actually get to the cluster from the public. And as you can see, I'm gonna see if we can see the application here running live, and you can too. And there you go, right? I have version number 3, and my application is running on this IP address, which is pretty cool. So let's go back and look at the pipeline because I want to show you. Now, we kind of got up to smoke test, right? Normally, I wouldn't have this approve destroy. This is a feature within CircleCI which gives the ability to have like breakpoints or approval points within your pipeline. So, remember I talked about some companies deploy applications from code, right, all the way through to production. Ideally, that's where you would like to be. But realistically, a lot of organizations don't like to operate that way, or, for whatever reason, it's not right or wrong. It's just the way that they operate, and that's okay. I got respect for that. But what this button here does, or this step here, is basically an approval. And what it does is it gives me the ability to actually destroy my cluster after. Normally, I wouldn't have this. Normally, I would say, all right, after the smoke test passes, then destroy the cluster. But actually, I would say after the smoke test either passes or fails, I still destroy the cluster, because who needs that extra cost, right? Who needs that stuff living? You don't really need it anymore, so you just destroy it. Again, right? This is just simply building infrastructure, deploying the release that you've just created, and then testing it so that when your code reviews come for this release, or your release managers come to kind of review what's going on before they push it out to production or to whatever target environment, they already know it was built for it was built into a Docker image, it was deployed to a Kubernetes cluster, and it was tested in that environment. So the probability of it failing in another environment should be a lot lower, right? Because you kind of sussed out a lot of things that could create a problem where your deployments will fail. So I'm going to go ahead and deploy or destroy this, right? And kick that off, right? So you saw that. I probably was too quick. Sorry about that. But basically, I clicked on it and asked me if I want to continue. And then my pipeline is now going to, jump into the next thing, which is destroying that cluster. And once all those things happen, this cluster shall be no more soon enough, right? So yeah, I think that's basically it, unless there's any questions on this. I know we're at time. I want to give people the opportunity to ask questions or just have discussions, whatever.
Awesome. Like Angel said, please submit your questions in the questions panel. He is your resource for the next 15 minutes or so. With that being said, we're going to go into the first question. The first one being, what are the benefits of not running extensive test suites on every pipeline build?
Yeah, the benefits of not running. So obviously, right, you want to get that fast feedback loop. That's what kind of continuous delivery and CICD and continuous integration is all about, is enabling the developer to work in an optimal manner. And the way we work optimally, it's kind of been proven already with just the adoption of all of these new concepts, is that the faster we know that we have a problem with the code we just wrote, the quicker we can resolve those issues and then jump into the next task in our list, right, to accomplish. So that's one of the benefits, right?
Awesome. And I do see that someone is wondering about a demo availability. I know that this presentation will be sent out to all attendees and registrants after it concludes. In terms of like the demo, specifically, is that
Oh,
something
yeah,
that CircleCI?
yeah, the code is available. Let me see if I'll pull it up real quick. Yeah, this is already like posted on, let me see if I find it here. Yeah, it's in the data punks. Yeah, I have it for you here. I can just pull it up if you think it's IAC-DO. And for whatever reason, this isn't, yeah, there it is. Yeah, so this is the project here. I can just paste it into the chat, I guess, or can people see the chat, I guess? I'll post it in there for folks.
They should be able to see it.
Yeah, I'm working on a Mac today, so I'm like, ugh, these keys. All right. Sorry, I jumped between Linux and Mac. So I posted the project there, and anybody can kind of, download it, play with it, whatever. I like to always share these demos with people because I know, they're getting started, and yeah, it's just nice to do that. So
That's
yeah, the
awesome. Thank you.
Kubernetes cluster is dead now, right? And again, it's a really cool way to kind of, again, test the applications in the environments where you're doing, and it's all done automatically, right? So the developer doesn't have to push or do much. They don't have to do much, and that's the kind of mantra of CircleCI is we're trying to make the developers' lives as easy as possible while enabling them to confidently build code as quickly as possible.
Amazing. That's definitely helpful. I can see that being a great resource. Okay, next question for you. Do failed tests constitute a failed build?
Depends. So let me show you why I say depend. It depends. So yes and no, right? Like it depends on the tool you're using. I'm trying to find one where things were, okay, this is a good example, I think. This is yeah. So remember this thing here says that my Docker push image ran. And as you can see, I had a lot of changes recently, right? Like I've been making quite a bit of changes to this. But if you dig in deep here, we actually ran a test, and guess what? It actually didn't work, right? It actually didn't work, but it passed. And why did it pass? It's because I basically set, let me show you where I set this. Actually, let's jump back to the config file. I set a setting here in the tool, right, to false. Now, had I set this to true, this thing would have blown up and it would have failed. So like all the way that CircleCI builds, or I should say jobs work, is if you have an exit code of 0, that means it passed. And you can see here, right, everything's exit code 0 because it's kind of like I guess a double negative. I told it, yeah, don't fail. And it didn't, right? So it told me it passed, but this is like I should say a false positive. Like, right, it passed, but it really didn't because it didn't even run the test. So I hope I'm not confusing anyone, but most of these builds and all these things that happen are based off of the simple thing that, right, if you look at all of your builds, if it's a 0, right, because it's only going to be, well, generally speaking, exit 1 or 0. 1 is obviously a failure and it will crash. And it will tell you, and it will stop. But then there's times where you build these dependencies that you really don't want, which is another thing. Blockers. I always go for like the fastest possible, so I do a lot of things at one time in parallel and concurrently. As you can see here, right, I'm doing a lot of things, and normally some places, right, but I do have a dependency here. You cannot deploy this if this fails, right? You can create the cluster and everything, but you can't, obviously you can't deploy this app if this cluster is not created because you won't have a place to deploy to. So the answer is yes, they can continue on, but you would have to kind of tweak the tool or the command that you're using, right?
Right.
I hope that
So
makes
then,
sense.
just like to clarify, does that lead to like less reliable tests and more flakiness in like the process of it all, or is that avoided?
Yeah, so yeah, it can definitely lead. If sometimes people turn those toggles on and off and they forget. And I've seen this where unfortunately, they've left it like that for weeks, and then there's a serious problem, and then they go back and well, everything passed. But if you reach back and once they do their kind of deep dive, they figure out like, oh wow, we toggled this and never kind of toggled it back, right? So those are like the same thing as any kind of troubleshooting within software development. These are things that can happen unintentionally, but they have a huge impact down the road.
Right. Okay. And we have another question here from Jack asking, how has CICD helped your organization from like a deadline point of view or product quality?
Oh, well, so with every it helps dramatically, right? So we actually have a report that I believe is going to be published pretty soon. So we have millions of basically, yeah, we have millions of users, and we run millions of lines of code every day, right? We do a lot of builds, millions of builds, and the reason why we're so popular is that we're automating all of these things that we used to do manually back in the day. And we're giving the developers and the operators the ability to uh, automate all of those manual processes, which again, right? Look at these build times; they're pretty quick, especially when you run things in parallel. This right here, sometimes you can't avoid it because what's happening here is I'm connecting to an external service, so I can't control how DigitalOcean optimizes their builds of their infrastructure and all that good stuff. But what I generally tell people is I have a gold standard of that I try to target, which is 1 minute builds, right? Everything I do within my builds, I want them to be done in 1 minute. Now, of course, that's not realistic, but it's a goal that I always kind of lean towards. And whenever I see like 4 minute builds, I start looking into why. And of course, there's reasonable reasons. In this case, I'm deploying this application to a Kubernetes cluster, and it's also building an ingress, right? Which is a load balancer, and that takes time. There's a lot of technical things happening that just by nature take some time to kind of connect the dots and make sure you got network traffic, routing, DNS things are occurring. There's a ton of things happening, and again, right? But to answer your question, yes, this does dramatically increase the velocity of your software release cycles. It also adds a hell of a lot of quality to them as well, because right, as you can see, you're adding tons of testing, and you can even run integration tests right in parallel. I generally try to tend to tell people, if there's different kind of segments to your pipeline as well, which you can define in a workflow. And you can actually have multiple workflows running. But I generally tell people to kind of, it's just like the agile concept, break things down into small manageable pieces. And then it gives you that flexibility to kind of, pick and choose and then optimize those things a little bit better, than having to optimize the whole damn thing, because that will be a real pain in the butt. I've tried both methods, but definitely it will help with both the reliability of your code, and of course, right, that also is dependent on how well your tests are designed, how well they're kind of the coverage of your tests, right? You can implement pretty much any tooling that you do manually in CI/CD and CircleCI, and right, it'll give you the results that you're used to without having much effort, right, to implement those things. So I hope that answered your question.
Yeah, it definitely seems like the abilities to kind of increase efficiency are huge. So that's awesome to hear. We've got another question from the audience asking, what are your thoughts on Chaos Monkey during smoke testing?
Yeah. So I just gave a workshop with Gremlin. There's a company called Gremlin, and their primary focus is chaos engineering. They have a platform that can help you as well ease, implement and adopt those chaos experiments. We actually have I do have a demo somewhere. So we're running out of time. I would love to show it to you, but basically, you can implement like the Gremlin tools. I mean, there's other companies, right? I'm just picking on Gremlin specifically because I just did a workshop with them, and it was pretty cool. And what we did was we implemented some tests. So we built a release, and then further down the pipeline, let's say maybe down here somewhere, we created a Kubernetes cluster. You can create it again, the same kind of process, maybe all the way up to here, and then you can have actually like chaos experiments running concurrently, but obviously dependent on this one deployed. But you can run those experiments, right? Now, of course, right, if you're doing chaos type experiments, those could really like crash the system, and if you're looking for that effect, that's cool. But sometimes, right, you can take the whole system out and then you're not testing anything. So you have to kind of be a little bit logical about those tests or those experiments when you're doing them. Like, if you're gonna thrash the CPU or the disk or clobber the CPU, you have to leave some room, some level of room for the cluster to survive for you to continue. But yes, you can do all of those things in the automation.
Right, awesome. Okay, and I think we have time for one more question for you, Angel.
All right.
And that is, can you share some final tips on optimizing pipelines?
Ooh, yeah. Those are my favorite. I've already mentioned kind of my duration, job duration. Try to target a reasonable timeline. I recommend everyone just target 1 minute and then see where you go from there. Again, you're going to have these exceptions because there's just things out of your control, and there's things that are just technically like they just take time, and that's okay as long as you're aware of them. But also keep an eye on them, right? Like, just don't just don't live with it is what I'm trying to say. Go back to it, iterate over, and give it a look maybe every month or so, 30 days. Like, can I get this a little bit faster? One of the other things that I see folks can do to help with the optimization of pipelines is just like I talked about smoke testing, right? Eliminate things that you don't really need, right? Do you really need to scan security scans at maybe further down a segment? Maybe you have like, you're going to promote this release to staging. You've already scanned it. I see people scan it again, right? And maybe that's a requirement. And in that case, then you can't do anything about it. But if you don't have that requirement and you're doing, repetitive things, get those things out of there. The whole point is you've already, as long as your code doesn't change and that environment is not changing, in any way, you don't need to, be redundant in these things. The other thing I could advise you to do as well is when you're running these pipeline builds inside of, like, let's say CircleCI, inside the tooling, the runtime itself, right? So what we do is we constitute, or we establish an executor, like I mentioned, which is the actual runtime. Now we have a variety of different ways to do this, but in all, at the end of the day, you have a virtual machine that's running this Docker container. Now you can tell in CircleCI, you can tell the platform to give you a certain sized resource class, which is the actual node underneath that's running all of these runtimes. And what I see a lot of people do is they kind of go on the maybe the low key, cheaper kind of option, which works for them initially, but eventually their code grows and you need more resources. Like, you need more CPU, maybe you need like 2 more cores, you need more RAM, maybe you need 16 gigs instead of 8. And we have this option of declaring the size of the runtime you're going to run in. And that dramatically helps your build times as well, especially if you're compiling things from source, which I see a lot of folks do, and that, it can take 20 minutes. But if you 20 minutes on like a low class, medium resource class, but if you put it on extra large, it takes, I don't know, minute and a half, right? So now you're shaving a ton of time off. So yeah, those are the kind of optimization tips I would suggest.
Yeah, those are definitely awesome. And unfortunately, we are out of time.
Oh
So with
no.
that, DZone.com would like to thank Angel for that phenomenal presentation. DZone would also like to thank CircleCI for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.
Thank you all. Be well.